let's start the video number 3. It's the end-to-end coverage of the heatmap generator. In video 2, I created this SVG file, right? This SVG file, and then as a review, that we can take a look at this SVG file. It looked like this. Okay, I just make it oversimplified so that it won't take too much time to draw. And then what I'm going to do is I've just dropped this SVG file into the canvas, and then it shows up like exactly what we have. Okay. So before we generate the heat map, there are a few steps to go through. The first thing is to decide how many APs are in this room, in this area. I allow it up to 9. But you can, if you want, you can modify the code to make it as many as you want. But for simplicity, let's make it 2. Okay, and then you can move this AP around to the place you like. So you can see there's a table below, and then there are a few things you can change. For example, if you move the position, you'll see the X and Y just follow along, right? You'll just record your location. If you push your mouse wheel, you'll see this number 1, this number in the middle will shrink. If you push toward yourself, you'll shrink. And then this is the height. So assuming you are looking from the top view, and then this transmitter will look larger because this number look larger, which means it's closer to you, so the height will increase. And then you can pick the band. So for example, I pick 5, it will become blue, and then this will go 5. And then the other is the power. Power, you need to double click it. And then this circle will become bigger. It means it's a higher transmission power. Size of number means the height, and the size of circle means power. Okay. And then the other thing is the observation height. Observation height is here. Push the wheel, your mouse wheel. So if you push it forward, it will become larger. Means closer to you. The height will be larger. So which means you are looking at this layout from the top view. So it's closer to you, it will be bigger, and the height will be larger. Okay, so this is the philosophy. Okay, so after all of these are done, then we are ready to generate heat map. Okay, let's make it different band. And then let's hide this somewhere. Let's see what is going to happen. And then you'll wait. It's actually very fast. Okay, so you'll see the shadow here. To show this is just an ordinary picture, I will save it. I'll save it as a picture. Like here. Okay, picture is here. Okay, so this is an ordinary picture. I can simply save it. This is ACDC. So you just right click and then save the photo, and then you'll get a heat map right away. So this becomes so convenient. So if you click this button, you'll see the 3D view. Okay. Okay, you can rotate it to view the different angle. And you can push your mouse wheel to zoom in to see whatever angle you want. And then you can use your right click to move to shift up horizontally or vertically or whatever direction you want. Okay, so this is the 3D view, and then as you can see, all the walls have the same height, and then all the furniture have the same height too. So this is deliberately designed in this way so as to minimize the number of parameters that we need to control. Okay, so So yeah, this is a simple case. We can look at a more general case. Yeah, for example, yeah, the 3D view. Yeah, for this one, yeah, the for this one, the 3D view will look much nicer. Yeah, so this is the 3D view. We can we can see all the detail, and then you can check the window height. They are all identical. Yeah, because it's extended from 2D, so we have to assume the parameter in the third direction. Okay. So, any questions? Danny, Danny is asking the background model, the background tool to generate a heat map, and yes, it is the NVIDIA Shiona RT. Yeah, that's the one we are using now. Okay. Danny is asking if there's any neural network involved, and the the answer is no. There's no neural network here, and for the Shana RT, everything is based on physical law and based on ray tracing. Yeah, for example, the heatmap back end tool that I use now, I emit a billion rays for every transmitter, a billion, because my PC is good enough, so I can handle a billion rays, and then find out the result power received at every corner. So and then that's how we generate heat map. Yeah, but if we want to get all those like neural network model involved, it's doable. Yeah. The important thing is that if we change the background model or background tool to generate a heat map, we can assume all the front end interface will remain the same, and so that's the whole purpose here. Yeah, so this is a very important detail, and I didn't mention this is very important. Yeah, if, for example, if we have like three AP, basically this does not count any mutual interference. Yeah, what I did is that I just take the maximum power of the three heat map and then create a new heat map. And the reason is that I assume those AP do not interfere with one another. And then if that assumption is true, then whatever user in this service area will associate with a correct AP, and then he can only see the strongest power received from that AP. So, for example, if an user is standing here, and you can receive a strong power here, and receive weaker power here, and even weaker power here, from this AP, and then what this user eventually see is gonna be the strongest power here. So that's the reason why I take the maximum value of the three heat map. So if you have nine AP, actually this background code is gonna run 9 times, and then generate 9 heat maps, and then eventually what you are gonna see is the maximum value of this 9 heat maps. That's very important too. Yeah, right now I just distinguish them by category, like glass and the wall and the door. Door are wooden wall door. Glass window are glass window, and wall are concrete walls. And I do not allow you to input the conductivity or permittivity, those kind of parameter. Yeah, and then so this is a pretty primitive implementation. I will summarize this talk. Yeah, to generate a heat map from end to end, it basically just drop in a layout, yeah, created by the layout tool. You cannot drop in a random SVG file. It does not work. Okay, you have to use the SVG exported from the layout tool, and then you can pick the number of AP you want to have, and then adjust the position, the frequency, the height, the power, and then adjust the view. This view height is actually the heat map, the height of the heat map at which altitude that you are measuring the heat map. Okay, and adjust all this number, and then you can click this button to see the heat map directly. Yeah, it take a little bit longer, yeah, because this is Shannon RT, so it's not so fast, and then because it has 4 AP, so you have to run 4 times. Okay, and then you get the heat map. You can just download it, and then you can see the 3D view. Yeah, so this is pretty much end-to-end demo of how to use this heat map tool. And then if you are interested in all the features, yeah, for example, I have this template, yeah, and I have a lot of control functions here and there. Yeah, you can watch video number 5. Yeah, that will be the feature introduction of the heat map tool.